Okay. So, who here was familiar with the slice method before tackling this problem? Have you guys never seen that before? So pretty much, let's say in this console log, we have a string, right? Okay? And it just console logs this. Just console logs that, right? Just the string. Now, slice is actually sort of like 2 uppercase and 2 lowercase. It's a method that can be used on strings. Also, it can be used on arrays. You guys haven't worked with arrays yet, so we'll focus on strings. So you pretty much do dot slice, and you give it a starting point, and you give it an ending point, and how many to slice off of from the starting point, and then you get SL. So the regular function of slice, it's a string, any string dot slice, invoke it. The first argument is the index at which it's going to start. So it's 0. It starts at S. Can you guys see this? Everyone's good? It starts at S, and then the second argument is how many, you know? So you have S, L, 2, right? So that's why this is SL. So that's what the slice function does. It's very useful. Also, I will be slacking out at the end of the lecture just a link to a website, MDN. It's Mozilla's kind of like developer guide they have a lot of things like the documentation on JavaScript. So definitely like if you just Google .slice MDN, it'll pop up on the page, and then you could read as much as you want about this, about any other method, about like equal equals or triple equals or whatever, you know? So I'll slack out a link to that later. But this is essentially what the slice does, right? So let's see what first thing to do with my slice. So first we'll make a function. This is a way to make a function, okay? This is another way to make a function. Const is another declaration thing, like let or var, but const can never be reassigned. So if I try to say my slice is equal to something else, it will throw an error because I made it a constant, okay? And then you set it equal to open parentheses, equals greater than sign. We call this a fat arrow, and then open up your curly braces. And that is a valid way of writing a function as well. I just wanted to show you guys this for a second. I will go back to the other way, but I will comment this out, okay? So we do function my slice, and I believe this function is going to take 3 things, right? It's going to take a string, it's going to take a start index, and it's going to take an end index, right? So the first thing we want to do is we want to check if these 2 things are being passed into the function. Because if they're not, and you try to reference inside your function a parameter that was not passed into it, like start and end will be undefined. They're not passed in, so they're undefined, and that will break your code. But slice lets you pass in nothing, okay? If you just do up here console.log a string dot slice and invoke it, it just returns the string. It returns a copy of the string. Because you don't tell it where to start, and you don't tell it where to end, so it automatically starts at 0, and it automatically goes to the end. And it just returns the actual string. So that's valid. Not passing in start and end is like an okay thing to do, okay? But since this is a function and we're not dotting off an actual string, we also have to pass in a string for this function. So there are 2 ways to do this. The first is saying Well, actually, okay. So first we have to see if start index is undefined, right? So if start is equal to undefined, we can just return string, right? We know we'll be calling this function later down here with a string and then start index and then an end index, right? So if I don't pass in that one, we know end is not defined, but we know that this is. So it's still going to start at 0, but this could be any number. But if we remove that, we know both of them are going to be undefined because there's nothing coming after this. If there's no second argument, there will never be a third argument, right? There has to be something here for there to be something here. So we just check if start is there. If it's undefined, then you just return the string. You're done. Who's confused by that? Anybody?
What is the? It's not understanding what. Can you like a use for it or like what?
Well, if you're writing a function, right? If you're writing like any kind of function at all, you don't know what kind of data is going to be thrown. You don't know like who's going to do what with your function, right? So you have to be prepared. Like if I do like this, if I do this, and I just pass in this string, and down here I say like, oh well, accessing like start, like string at start or something, but you never pass it in. It's going to be string at undefined, and that will break your code. So you have to check and see if this is undefined. And if it is, then you just return the string. You don't want to run the rest of the function, because remember, if you return, everything below it doesn't run. The function ends and you get your value. Yeah.
The bottom of this says don't use the slice.
Yeah, we're not.
Okay.
We're just saying start triple equals undefined, and if it is, you're just going to return the string immediately. That's what we're doing. That's it. So far. Yeah, don't use the slice method if you're trying to write the slice method, you know? But, okay. So the next thing to do is to check end index, right? So, if end is equal to undefined, so this means, since this code is going to run over here, we know that start is defined, right? This check happened, and we're going to skip over this if block, so we're going to go to the next line of code, right? Which is checking end. If end is undefined, what happens? What do you want to do if they don't give you a stopping point? Yeah. Beginning of that index to the end, right? Yeah, you just never stop until you hit the last point of the string, right? You just want to go until the end. If we're not telling you when to end, just go to the end. So we can just do end equals string dot length. So now you can do this. You can reassign parameters. So now we're saying, okay, if this parameter is equal to undefined, we're going to change it. It's not going to be undefined anymore. It's going to be the length of that string. So we know where to stop. Okay? Yeah.
Is it possible to use like the weighing operator in those? So like if then start double ampersand,
Yeah, so you can, I mean, okay, so this, you could do this too if you wanted to. But, so the reason I chose not to do this, because I like showing you guys some tricks, but like the reason I chose not to do this is because if what we're checking for here is not if it's truthy or false, right? Because you know that the if statement is always going to check and see if this is true or false. And undefined is false, right? So if this is true, I forgot the bang. So like you're saying, if this is true, then return the string. So if you're saying like bang string, bang undefined, then that would run as well. But if it was also an empty string, a 0, no, or something that other falsy things, this would also run. Undefined is very specific to something if you're to a parameter if it's not being passed in. That is 100% always going to be equal to undefined. So this is a very specific check. Because if that was a 0 and you did bang start, then that would be wrong actually. Because 0 is false. Get it? So actually you couldn't do that. Okay? Okay. So now that we have these two conditionals, we can say let results string equal to empty string. Because we know that we have our original string, and if we have a start point and an end point, which by this point we have, we're not going to hit this if there's a start point, and if there's no end point, we're just going to make it something else. Now, we're going to go through the original string, we're going to see where we're going to start and where we're going to end. We're going to take those characters and put them into the result string, into another string. So how do we do that? We use a for loop, okay? It's easy. I'll show you. So, you say, first you start your for block like this, right? I want you guys to practice just doing this first. For space, open paren, close paren, open curly brace, close curly brace. So you know that there won't be any any syntax errors with misplaced brackets, curly braces, okay? So first you start like this, and then you have to initialize a variable, or something that will be incremented every time. So I say let I, set it equal to 0, semicolon, right? Then you do, oh no, you don't set it equal to 0, that's my bad. In this case, we want to start looping through the string when? At the start, right? At the start index that's being passed in. So we're going to set I equal to start. Okay? So the next step will be until, we want to continue looping through until I is less than the end. Right? We want to go up until it's the end, right? So then, here, we just increment every time because you know you want to hit every single character. So, if you don't want to be confused, you can say, you can create a variable inside this for loop and say let current car, right? Current character. And you could set that equal to string at I. So every time this loop is going down, every time we're looping through that string at the start point to the end point, this current character will be different because I will be different. Does everyone understand that? At each loop, this will be a different character in the string. Okay? Does everyone understand that? Okay. So then, what should we do after this? To this thing, right? Result string. So here we do results string plus equals. We do results string plus equals current car. Then you return result string. So if you pass in this, if you call my slice with that, you just get this as a string, right? If you say start at if you say start at 3 and don't pass in an end index, we'll start at the S, you know? And if you do give it an end index, you get nothing. Wait a second. Is this wrong or something? Huh? Oh, it does it? I think I did something wrong. So I is less than n. I plus plus current character equal that. Slice 1 plus equals current character. Do like 0 to 2. Why does this work? Oh, maybe because of the spaces are weird. So if you get like 5 and 6, you'll get the I, right? 0, 1, 2, 3, 4, 5. Aha. Oh, okay, yeah. Yeah, this works. Sorry. I just got confused. Yeah. You don't have a question? Oh, okay. So you see, if you pass in a 5, we're going to start at the 5th index in the string. So it starts at 0, right? So the t is 0, and the 5th index is this I. And you're going to say going until index 6, but not including that. So you just get the I, you know? It starts at that I. It slices off everything after that, because that's where the index is. At index 6, everything after that point. Okay? Like if you did 0, start at 0, and you just go one place further, you get T. If you go 100 places further, oh shit, no, this is wrong. Yeah. Well, if this is bigger, oh, actually, this should have a different case, because I'm pretty sure in slice, if you pass in like all this, and you say start at 3, it would go like that. Oh, this is weird. Oh no, I'm not doing anything. Console log dot slice. This is so confusing. Do this. Oh, so that doesn't. That just returns nothing. Oh, okay. Yeah. Okay. That makes sense, I guess. Yeah. So there has to be kind of like a stop case. So you could do like or I is greater than string dot length. So if you do this, yeah, okay. No, this is wrong. Oh shit, I did something weird. You think this is right? No, because like you can't go. Yeah, but this is wrong. Like, you see? Because you're not stopping at the end of the string. Like you have to check and see. Oh, so you check if n is undefined, or end is greater than string dot length. Yeah, okay, cool. So slice does this for you. Is that not in the solution?
No, it says then it's
Yeah, so slice, if you say like, okay, start at 0 and go to 1,000,000, but the string is like has a length of 1, it will just return the string because there's nothing else there. So here you check to see if this is passed in at all end, but you also have to check and see if end is bigger than the string. Because like I showed you before yesterday, if you try to access a string at an index that doesn't exist in the string, if you were saying like an index of the word end, the string end, E-N-D, right? At index 6 is nothing. There's nothing there because there's 3 characters. So that's undefined as well. So you saw before, when I put in 1,000 and we weren't checking that, it would not only be a string of what we were, of this, but it would be also undefined, 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 you know? So this is a better solution because you're checking one more thing. Okay? You guys good on this? Yeah. What's going on? So let's walk through the problem and see what happens when you pass something in. Okay? Let me make this a little shorter. Let's have this over, this and this. Okay. So let's pass in A, B, C, D. Okay? And we're going to say start at 1 and end at 3. So what this is saying, I'm pretty sure, is that we're going to be starting at this B. Can you see? Okay. We're going to be starting at this B because that's at index 1, right? And then we're going to slice this one out, slice index 2 out, but not this one, not index 3. Stop before that. So we should, with this, we should get a string BC, okay? Do you agree? Right? Okay. So let's pass in ABCD to this. We'll pass in ABC here, and then well, I won't do that because that's confusing. But like, we're gonna pass in ABCD, a 1 and a 3, okay? First things first, let's check. Does start equal undefined? No. Start is 1. This is skipped over. Then we check, does end equal undefined? No, it doesn't. So this is false. Then you check this side of the OR statement. Is end greater than string.length? End is 3, and the string's length is 4. So that is also false, so we skip reassigning end. So now that we've checked and seen that we have like good parameters, we're going to go down and doing the actual logic, the actual slicing, okay? So we set up a result string, something that we could just push things into, okay? And then we set up our for loop. Now, you don't want to start at 0. You don't want to hard code where you're starting, right? Because this function gives you the capability to pick where you're starting from. So that's why I'm saying let I equal start. We're gonna initiate I at the start value that was inputted into the function as the parameter, okay? So we start I there, so it's gonna start at 1. So I is 1. And then we're gonna go until I is less than end is no longer true. So when I is equal to end, this will stop. And then we're going to increment I by 1 every loop. Is everyone okay with that? Yeah.
very general question about like how do you know when certain words are like a keyword or it's an object or it's like how would I know that like JavaScript knows to start?
Oh, well, start is something that I defined when I'm writing the function. Like start isn't a keyword, start is a parameter. This start up here, if you went through and changed all of that to like monkey, like this function would still run. This is just something that I made, you know? You don't have to do that. But I just made it start because it's more clear throughout the function. So parameters aren't keywords, they're just things that you make. But like keywords are like while, for, let, const, are. Yeah, undefined, you can't name anything undefined. Can't. Yeah, there's just like a bunch of things. I can't like list them all out for you. Yeah, it's gonna, no, this is gonna look for the words. No, this is saying like, oh, what, like JavaScript will read this line. It's gonna see this word start. It's gonna say, I have absolutely no idea what this is. And it's gonna look for what it is. And it's defined here as a parameter to this function. And the thing that was passed into it is a 1. So this is a 1. You know?
I actually understand the question she's asking, and I guess, correct me if I'm wrong, but like, are you saying by using the word start, JavaScript knows to like literally look at the start as...
No.
Okay.
No. Start. If I try to run this function and I call this start index, there would be a break because start isn't defined anywhere. You're defining what start is by putting it inside of the function declarations, like parentheses. It's one of the parameters. Okay. So when this is a parameter start, I can now use this word start everywhere inside of the function. It's not a keyword, it's just literally the name of a variable. It's the same thing as doing like let start, right? Then you could use start everywhere. But you can't say let start here because start is already defined over here. Because you can't like make another variable that's the same name, you know? Yeah.
String is the type, and then the start in the end can be anything, any sort of word or any sort of string. What it says, the next position is where it says begin, and then the next position says and as you define it.
So no, so we are assuming that these will always be numbers, and we check to see that if it wasn't passed in at all, because if it's not passed in at all, it's undefined. Like if you go up here and you say let example, and you console.log example, example is undefined because you don't set it equal to anything. It's not defined, it wasn't like assigned a value. This right here is the same thing as this, basically. Like you're saying you're defining start when you're defining your function mySlice. So this can be literally anything. I can pass true into here. It'll break the function because we're not prepared for that. But like you can pass whatever you want, and whatever you pass into this function here, in this position, will be that start. Whatever you pass into the first position will be string. That's how functions work pretty much. Like when you're defining the function, you decide how many things could be passed into your functions. I could pass in like a fourth and fifth and sixth thing. It won't cause an error, but the function's not gonna. It doesn't know because they're not defined up here. So none of the code will ever reference any of those things, you know? So you define how many things will be referenced in a particular order for when they're passed in, you know? The first thing's always going to be the string. The second thing will always be the start index. The first thing will always be the end index. And I know that because that's how I want it to work. So since I know that that's how I want it to work, I will call this string myself because it will help me know down the code like what it is. Oh, this is the string. The start, oh, this is the start. And oh, this is where it should end, you know? I'm naming those things myself, so I know when I'm writing the code, it's not just a bunch of nonsense words. So strings start and end are not like keywords in JavaScript. They're things that I'm writing, okay? Yeah.
So like basically depending on the problem, you just choose different words that are
Exactly, yeah. 100%. If this problem wasn't looking for a start and ending index or something else, I don't know, I would call it whatever, you know? To help me as a developer, and to help other people who will read your code, because you will never be the only person that's reading the code that you're writing, ever. That's never going to happen. Yeah.
You could start at 5, you don't need to start at 2. Like, why are you starting at
What do you mean, why am I starting at that?
You said your start equals
Your start equals undefined
undefined.
if you don't pass that in. If you pass, like here we're passing in a 1. If you don't pass anything after that, start will be undefined. Well, that's the thing. So you don't know if you slice gives you the option to just pass in nothing. So we have to prepare for that. And that's why we have to see, oh, well, what happens if this or this or this? You have to be prepared for every time. So because you have to be prepared for 3 parameters, at most 3 parameters, you have to be prepared for them. You have to write 3 parameters in the definition of your function. But if you don't need the second and last parameter, then you have to be prepared for what happens if they're not like put into the function. What happens? Well, we do know what happens if they're not put into the function but defined as parameters, that start will be undefined. That's what start will equal in this function. Same thing with end. Okay? So you guys okay? Like for real? Not really?
How would someone use this, like, in a job?
Huh?
How would you use this in a job?
Writing functions?
Like, this particular one, like, what are we getting out of this?
Nothing. You're just like practicing writing code. Practicing functions, knowing how things work, how strings work, how loops work. That's what this exercise is for. Like, you're never going to have to write a slice function. The slice just exists on strings, you know? So you don't need to do that. But this is just like a good way to practice problem solving, because it's not like an easy thing to do. This isn't like an easy problem for people that don't know, who don't have like a lot of experience with computer science, you know? It's a little difficult, so it's okay to be confused right now.
See, like, when you put a certain setup, like if you're looking for a certain, for finance or something, a certain set of percentage or a certain set of amount, and you're running through a lot of data in your chart, you're narrowing down it and you're trying to slice out this, you're looking for this certain.
Well, see, like slice, I said, is also for arrays, right? So arrays are just complex data types that hold an ordered set of different data types. Think about that for a second. You could use the dot slice method on that, but it returns a copy of the array. So you will never mutate original data. So that's why slice is actually really cool for managing large amounts of data. But, yeah. Okay, so let's continue going through the function. So the for loop, I is equal to the start, and you want to go until the end. And we know at this point start and end are defined because we made it past this. We made it past this, and we made it past this. So it's always going to be something. So then you pull out, so if you want to access characters in a string, you do like that string, bracket, a number, right? The string at the index. So you know I is a number, and I is going to be where we want to start, and it's going to go until when we end. So you do string at I, and this will change every time. I will always keep getting bigger, so you will go to every character in the string where we want to start and where we want to stop, because that's defined up here. So we set current character equal to that, And then we just put that current character into result string, saying result string plus equals current character. Then, when we're done, we'll just return the string. And that's that. Yeah. Yeah. So we're starting at 1. Yeah, so we're starting at 1, right? So first thing, we're going to say string at 1, right? I is 1 the first time, correct? Everyone's good on that? So string at 1 is B. So B will be added to result string. So result string is now B. Then we hit the bottom of the for loop block. It checks if this is true. I mean, if this is false, it's not. It's still true because I, which is 1, is less than end, which is 3. So then I is incremented and now I is 2. So current character is now equal to string at 2. Oh, actually, no, it increments it first before it checks. Sorry. So string at 2, at index 2, it's C, right? So current character is now the letter C, and result string, you put it into result string, so result string is now BC. Then you increment. So I is now 3. Now that I is 3, you check to see if 3 is less than end. That's not true. 3 is end. End is 3, right? So 3 is equal to 3. 3 is not less than 3. So you break out of the for loop and you don't do it again. If you wanted that one, you could say this. You know? Then you would get the D. But you don't, because that's not how slice works. And the point of the problem is to write the slice function yourself. I can do like one more problem quickly. Would you guys want that? Which problem would you want me to do? The bacteria? Yeah, sure. What do you even have to do in this problem?
There's like you have like your start, how many bacteria you start with, and like your goal at the end, like say you want to go like 100 in the end instead of 1, okay? And then examples every 20 minutes, so you can see how many like those cycles.
Okay.
Take to
Okay. So this function is going to be called bacteria time, right? And we'll have current num, and we'll have target num. Okay? So do you have to check and see if the target number is smaller than this?
It has to be greater than, and if it's equal to or less than, you have to produce a string that says target number cannot be smaller than.
Okay, so if target num,
Or it says target num should be larger than current.
okay, so if target num is less than current num, or equal,
It just says it's smaller than.
okay, so small. Return a string that says what target num is what? Is too small? We'll just do too small, whatever. Doesn't really matter. But this is checking basically if the target number is smaller than the current number, then you return that string. That's what that if statement does. And if I'm understanding the problem correctly, you have a current number of bacteria, and you want to see how long it'll take you to get to the target number, right? Right? Yeah, so if the current number is bigger than the target number, then it doesn't make any sense. Like, what are you looking for? You've surpassed your target number. and it's not going to go down. It only goes up because bacteria just multiply, right? So in this case now that we know that it's smaller than the current number, we can do let minutes, and you could set that equal to 0. So because I'm setting minutes here outside of a loop, what kind of loop do you think I'm going to use? I'll use a while loop, right? So we know that minutes is 0. Right now we're starting at 0 minutes. Time hasn't started yet. So we check while the current num is less than the target num. While the current num is less than the target num. And then outside of here, we can just go ahead and return minutes. Because that's the goal, right? So what happens if current num is target num? You just return 0, right? If you have the number that you're looking for, it doesn't take any amount of minutes, so you return 0. And you know that you'll return 0 if this is equal to this, because this statement is not true. It's just never going to be true. If this is not less than this is this, you know? So if you set minutes out here, you won't enter the while loop, and you'll return 0. So that already takes care of that case, right? So, but while the current number is less than the target number, we can just do current num plus equals, times equals, because it goes time by time, right? Times equals 2. No, current num times equals 2, yeah. So this doubles, wait, 1 second. So this doubles, right? Because after every 20 minutes, it will double, right? And then you do target num plus equals, not target num, minutes plus equals 20. So eventually, the target number, you see that the target number is never getting bigger inside of this while loop. The target is the target we're looking for. But as time goes on, the current number of bacteria is going to grow. It's going to double. So that's why current number of bacteria, is times equal 2. Times equal is the same thing as plus equal, the same thing as minus equal. It's just current num is equal to current num times 2. Double, right? So first thing we'll double it, and then we'll add minutes to 20. Add 20 to minutes. So then, at the end, minutes plus equals 20 is the last thing. So then, it checks again. Is current number still less than target number? And this thing will break eventually because we're always multiplying current number by 2. Yeah.
Is there anything that jumps out at you when you hear a problem solved or a loop or a while loop?
Like a keyword in this situation? So, when I'm ever traversing through something, I usually use for loops, right? Because then you know, like, I is 0, you're starting it at the beginning and going up until a certain point. You know that. Here, we don't really know, like, where we're starting, where we're ending kind of thing. This is kind of like, you have a current number and a target number. You could write this in a for loop, but it kind of makes more sense to just keep doing something over and over again until a certain point. In a while, I don't know, that just kind of like makes more sense to do it in a while loop, but this could be done in a for loop as well.
You can do it in a for loop, but you would want the I to go until it hits target number to start.
If you did this in a for loop, I think I would be the current number,
Yeah.
and then each time, instead of I plus plus, it would be I times equals 2. and you would go until I is less than target. It'd be the same thing. But it's like, I don't know. For me, like writing for loops is kind of like robotic almost. Like it's usually always you start at 0, you always increment by 1, you always go until the end of something. I mean, little things change obviously, but so that's why I'm always automatically writing for loops. It's easier for me. But this is useful as well. Whatever makes more sense to you guys, you should use. Honestly, there's no difference, really. Except here you have to. Here it's like you have to define things in your code. Like you have to like increment things in your code around other things. So you have to be conscious of that. Whereas in a for loop, it does it for you. It would just look like this. It would be, well, hold on. Let me just see if this is correct. So if you write bacteria time and you call it like 5 and you want to get like 200, right? I don't know if this is right. What's one of the test cases? Oh, so this is correct? Okay, cool. What's one of the test cases? 1 and 8. And this should get what? 6? 60? Okay. Is that correct, right? Okay, cool. I don't have time to think about that. Think about this math. But what's it called? So if we do this, we'll still define minutes out here. And we'll do for let's I equal current number. Current num. I is less than target num. I times equals 2. And then here you just do minutes plus equals 20. Cool. Oh, shit. Yeah, so it's the same thing. Either or, whatever you guys want. But like, I don't know, it just gets weird writing this differently over and over again. Like you have to define, okay, what am I going to do here? What am I going to do here? If you're writing like something like that's different than the norm, I guess, it'd be easier, it'd make more sense to do it like in an actual function, whereas in one line gets a little weird, you know? So I don't know, it's whatever you guys want. Does everyone understand why this function works though? What do you mean how it knows to do this? So if you want, we can console log at the beginning. We could do console.log minutes. So the for loop, if you remember, the first thing it does, and it does once only in the beginning, is it initializes something, and that's I. So we're going to set I to current num, right? And the way for loops work is like, it first checks to see if this statement is true. I is current num is 1. 1 is less than the target, 8. So this is true, so it's going to run. Then when it finishes running all the code in the for loop, so first thing, the only thing we do in this code is minutes plus equals 20. So you add 20 to 0, right? Then it increments I defined by how much you want over here. So I times equals 2. I is now 2, right? So then it goes back and checks, hey, is this still true? It is, does that again. Plus equals 20, you get 40. Then It does this behind the for loop does it behind. You don't have to like write it in here, like in a flowing way. You know, it just does this at the end of whenever you're done with your code. So now 2 times equals 2 is 4, right? 4 is still less than 8, so this will continue to run. And you'll get 60. So then you get 60, and then 4 times equals 2 is 8, right? Is 8 less than the target number? No. Loop stops. Make more sense? Any other questions on this problem? Before we jump into the lecture? Alright, cool. So, today, one second, we will be talking about coercion and truthiness. So this is just kind of like weird aspects to JavaScript's language, okay? JavaScript is kind of a weird language. It does a lot of things behind the scene that don't really make any sense sometimes, but other times they do. So, console.log type of, are you guys familiar with type of? Right? Type of 2. You got a number, right? And this is a string, right? In quotes, 2 is a string, right? What if you say let num for string equal to 2 plus 2? What is going to happen now? It's not they both become a string. It's the plus sign sees that you're adding a string, that there's a string on one side of it, but then there's a number on the other side. So what this plus sign does is it coerces this into a string, so it's like you're adding string 2 plus string 2. So if you console, it's not going to be 4, it's going to be 22, but this is a string. That's what type coercion is. It basically takes, it sees that you're trying to add 2 things of a different type, and then it says, JavaScript does this behind the scenes for you. It takes this 2, makes it a string, and then it adds those 2 together. So you get 22 and not a string of 4. There's no mathematics happening here. It's just this string plus this string merged together. So you guys, yeah. No, it doesn't. It doesn't. It's still going to be a string. That's what the plus operator does. It says if you're ever trying to add a string and a number, it's always going to be a string. Any number to anything. So if you do 2 plus 5 plus 6 plus 8 plus that, it adds all these together, and then it adds the string at the end. But it's still a type string. So 2 plus 5 plus 6 plus 8 is 21. Plus a string 2 is 21, 212, right? And it's a string. So that's why it could get a little weird in things like this. And this doesn't matter if this is at the end or over here. But the result will be different. The string will be different. It's not adding 5 plus 6 plus 8 first and then putting it into a string. It's going from left to right. So you have this string 2 and it says oh, and it puts the 5 in there, and then it puts the 6 in there, and it puts the 8 in there. And before it puts it in there, it coerces it to a string. Okay? Any questions? Yeah.
Is there a hierarchy? Like, what if you put
know if you could do this. Yeah, it's still that. I don't think
So that thing can be equal to number or
huh. So this works for some reason. But so yeah, to make it a string, like if you had numbers and if you had like any other value to a string, it's going to be a string. Like if you do if you do like 5 plus undefined, you get 5 undefined, but it's a string. It's just for strings, really. If there's not a string present, I think if you just do like this, like, I think you get not a number. So, not a number. Yeah, not a number is kind of weird. It's not like a type. It's I think it's like a property off of the global number object, which is something I want to get into right after I finish talking about this. But not a number is like it's kind of weird. Like if you do NaN is equal to NaN, like this is false. Oh, I'm doing this thing. Wait, hold on. So if you do like NaN is equal to NaN, you have false. They're not like, I don't really know anything about like not a number, but NaN stands for not a number, and it happens when you try to add types that are numbers to something that isn't a legal number. That's, I think, is the actual definition of what happens. Something that's not a legal number. But if you try to add a number to a string, it says, okay, I'm going to make this a string. You know? Yeah.
When you have like 5 without the quotes and it's a number, we'll just try to add it because undefined is considered a number type.
No, type of undefined is undefined. Undefined, it's its own type. It will try to add it because you're doing plus. But the results...
But if you do it with like another string, it would just combine. What is it?
Wait, say that again?
On the notes,
Concatenation. Concatenation is like a string plus a string.
is that why when you do it, when you have 5 as a string?
When you have 5 as a string, it's basically concatenated. Yeah. It coerces, but it's not concatenating the type undefined. It coerces this into a string first. That is undefined. That is a string.
So it's kind of acting the same way if you were to use a string and a number.
Yeah, pretty much. So, there's these. I think you guys have heard me talk about these global objects a couple times, right? So there are these things, global objects, and it's just capital. It's just capital string, right? There's a capital string, there's a capital number, there's a capital Boolean, there's a capital object, capital array. Yeah, we'll go with that. And these are global objects. This is the global string object. This is the global number object, the global Boolean object. And these will be available to you at all times to use if you want to. Let's worry about string for now. If you do string parentheses, this number, you get a string 5. This is called explicit coercion. When you yourself are running some kind of function to make something into a different type. Like this. You were saying, you were accessing the global string object, which is always available to you, invoking it and passing in a number. This is making that number a string. So if you do like type of this, you get string. Type of, if you pass in undefined, You get string, right? It works the same way as plus, but this is a lot more explicit. Because, let's forget about strings for a second, and let's play with another one, the global number object. And this works in the same way. I pass in a string 5, it gives you a 5. Hey, is that a string or is that a number? It's a number. So if you pass in number, a string that's actually a number, that is explicitly coercing it into a type number. But let's say you pass in this. That is when not a number comes into play. You're trying to coerce something into a number that can't be coerced into a number. Because a string of 3 B's is not, it's just not a number. So it tells you it's not a number, okay? Oh, like this? No, that's not how this works. Same thing. It goes by numerics. Like, this is a valid string, they're words. JavaScript doesn't really understand the English language, you know? It just sees these characters, looks at their values, and checks what they are. You know? So if the character was like a 0, if the character is a 0, you get 0. If the character is a capital O, you get not a number. You know what I'm saying? So this is explicit, right? This, I forgot the terminology for it, but this is not explicit. This is something that you're not telling JavaScript to do. It's just doing it for you behind the scenes. Passing a string into the number, global number object is saying, okay, try and make this into a number. Like, that's what I'm telling you to do. This is what this function does, you know? So, before we move on, there's something else I want to show you about, and that is double equals versus triple equals. So, when people say triple equals, it's like deep equality. Double equals, I would really recommend never to use. Because double equals coerces types without you wanting them to be coerced, right? So you could say 5 double equals 5, and you'll get true, right? It is 5 is equal to 5. But is 5 equal to a string 5? Should be false, right? But it's true. Because the double equals is coercing this 5 into a string. And it's saying, okay, this is true. But if you do triple equals, it looks at the deep value, and it's false. Because I don't even know of a use case where you would want the number 5 and the string 5 to be equal. I don't really know of any use case. So really, like, double equals, I would really stay away from. Double equals is super weird. Like, it says that empty string and false are equal. Like, that's not true. They're both falsy. An empty string is a falsy value, but this is a Boolean, and this is an empty string. So, use the triple equals, and nothing will be coerced, and you'll see that they're false. Cool. So, let's talk about Booleans real quick. So Booleans also have a global Boolean object. And that makes everything into a Boolean. Because anything is either truthy or false. It's either true or false. So if you put true into here, you just get true. If you put a string into here, you get true. A string is a truthy value. An empty string is a falsy value. A string with a space is true. A number is true. 0 is false. Do you see what's going on? It's returning, it's coercing whatever I'm passing this into true or false. And it's the same logic as the number coercing something into a number, or the string coercing something, anything really, into a string. It's based because it says if it's truthy or falsy, and then it returns true or false. So another thing that you guys don't know about are arrays, which are basically things in between brackets, like this. This is an array of numbers, or an object, which is key value pairs. So you could say hello is equal to a string hello, right? So if you did a Boolean, let's comment this out. If you did a Boolean of this array, you'll get true. And if there's nothing inside of the array, you also get true. If you do a Boolean, of this object, you get true, right? We'll cover objects and arrays later, so don't worry about it right now, but I just want to show you this. You get true, right? If you get an object with nothing inside of it, you also get true. Objects and arrays, no matter if they have length or not, are always true. Always true values. They're always true. Yeah.
So should we, this is just something that we should just memorize, right? We're in the streets.
Pretty much, this is that's the deal. If this is really memorization, sort of. But also, you don't really need to try and memorize things, because you're always going to encounter oh wait, this is actually true. This is always going to happen. You're going to run into these things and you'll remember over time. So, but yeah, this is pure memory. This is pure memorization. Oh, this is this. Okay, now I know that. Yeah. I can't remember. We'll go over that in the slides. The difference between explicit and implicit is one of them is the global, and the other one is using double equals or plus. I think implicit is the double equals or plus. Something that JavaScript is just doing without you telling it explicitly. But yeah, when you do a function, the Boolean global object, pass something into it, that's okay, I'm only doing this because I want to see if this is true or false. You know what I'm saying? Yeah. So negative numbers are also true. True. So there's one more thing I want to go over before I get into the slides. Because these slides are actually really helpful. It shows everything line by line, and it's because this is more memorization stuff than logical. Oh, if this does this, then this does. This is real just kind of got to learn JavaScript's quirks, and coercion is one of them. That's a quirk. A lot of other languages don't do this kind of stuff. So the other thing I want to go over is this bang operator, right? Bang true is false. Bang false is true. There's another. So if you let me just console log this. I say, so you see, if I do bang true, you get false, and if you do bang false, you get true. I say the bang operator, and mostly everyone does, but this is also known as the not operator. It coerces something into a Boolean, but like reverses it. So not true, bang true, coerce that into a Boolean, but reverse it and you get false. So if you do not a string of true, not an empty string, you get false true. Because any string, this is a string, this isn't a Boolean anymore, any string is truthy, right? But with the bang operator in front of it, it says, okay, not this string, so that is false. And an empty string with no characters inside of it is falsy, but the bang reverses it. But it always returns a Boolean, okay? Truthy and falsy is if you coerce it into a Boolean, it will be true if it's truthy. So like what we were doing over here with the Boolean thing, right? Whatever you pass into here, if the result is true, that value is truthy. Something that passes an if statement is truthy. Something that you say truthy and falsy. Because you don't say like true or false, because true and false are actual values, specific Boolean values. But like an empty string is not false, it's an empty string. It's different than false. It's an empty string. But it's false because if you turn it into a Boolean, it would be false. Do you get what I'm saying? Like it's a little confusing, like truthy, falsy. That's not like real English, I guess. But since true and false are actual values in JavaScript, they're the two Booleans. If you just say like this empty string is false, no, it's not. It's an empty string. False is something completely else. So you say truthy, falsy. An empty string is falsy. But the bang operator basically returns a Boolean inverted. Does everyone understand that? So, another thing you could do is bang bang. Bang bang is shorthand for making it a Boolean. Not inversed, just like coercing it into a Boolean. Same thing as like a Boolean, like, let's say console.log. We'll do down here console.log bang bang undefined triple equals to bang bang true empty string. And you get true. Can somebody explain to me why this statement is true? It's good. What do you mean? You can think of this like this, right? One bang is inverted, so another bang, you invert it back. So that's true. And undefined, but the main point is that this is becoming a Boolean now, right? This is no longer undefined and empty string. This is now false, and this is now false, right? So even this, if you invert one and invert the other, this is still going to be true because they're both false. But if you do this, this is false because the value of undefined and the value of an empty string are completely different. But the bang operators coerce things to Booleans, and Booleans are either true or false. The value is true and the value false. So, a bang here and a bang here will make both of these things true, and true is triple equals to true. Bang bang just coerces it into, this is the same thing as doing this, like, It's the same thing. A bang bang is the same thing as doing capital Boolean with that. Any questions?
Like there's a true is empty space starts on false before the bang bangs are placed in front of it. How do they end up being equal to each other at the end?
Because, so, okay, before the Boolean is there, and before the bang bang is there, right, you just have undefined and an empty string.
What's true, what's false?
No, both are false.
Oh, both are false. Okay,
Both
I
are
thought
false.
that
Undefined
was
is
the case,
false,
right?
and string, empty string is false.
Okay, and I thought you said undefined was true.
Then you pass undefined to a global Boolean object that makes it a Boolean. And what it does is check if it's truthy or falsy. Undefined is falsy, so that returns false. So this you can think of as just being false. Just false, not Boolean undefined. This is false. Bang bang does the same thing. Whatever follows, it will say, is this truthy or is this falsy? Empty string is falsy, so that returns false as well. And then false does triple equals false. You guys get it? Sort of? We'll go over everything again in the slides. So let's check it out. If this thing ever starts. Alright, I'll just do it like this. I can't? Are you serious? Alright, this isn't working. I got other sides. Okay. Coercion and truthiness. So we will talk about explicit coercion. Okay, yeah. So explicit coercion is using like the global booleans. Okay? Global booleans, global string, global number. And implicit coercion we will also talk about, and that's concatenation and loose equality operator. Okay? And then we will talk about coercing things to booleans, truthiness. So we'll see which values are truthy and falsy, conditional expressions, bang operator, and we'll also talk about logical operators. Okay? So explicit coercion. Coercion occurs when the type of a value is changed to a new type. That's what coercion is. Okay? So explicit coercion happens when we use one of the built-in global objects to create a value of a new type. So in this example, you say let num is equal to 10. You console log type of num, you get number. No one disagrees with me, right? Like that's just what happens. So then you say let string is going to be equal to capital S string invoked with this variable num. This capital string is the string global object. Okay? You don't have to worry too much about the global objects. It's kind of a bigger topic. Well, just know that they're there, like this. Then you console log string. It's still going to be 10 in the terminal, but type of string will be a string. Is everyone okay with this? Everyone understand how that works? Okay. So the same thing can happen with the number. As I showed you, you say let string equal a string of 1000. To us, it looks like 1,000. To computers, it's not 1,000. To computers, it's a string with those specific characters. Okay? Console.log type of string, you get a string, right? That's what this is. It's a string. Then you say let num equal capital number, the global number object, and you pass that string into it. And then you console log num, you get 1,000. It still looks like that in the terminal, but it's a number now. Is everyone okay with this? Same thing as the last slide, but these are numbers. Cool. So implicit coercion also changes the type of the value, and unlike explicit coercion, implicit coercion is something that JavaScript does for us behind the scenes. This behavior can be very helpful, but it's important to understand how it works so we can anticipate what our code will do. So implicit coercion with the plus sign, right? Let sum equals 10 plus 20. What's 10 plus 20? That's awesome. Let concatenated string equal string 10 plus string 20. What's that going to be?
10.
Yeah, in one string. Good job, guys. So console log sum, and console log concatenated string, you get 30 and 10, 20. Then you console log not sure, which is going to be 10 plus a string 20. And in the console, it looks like 10, 20. It looks like the same thing as the concatenated string, right? That's because it is. Do I say the type? No. It is a type string, okay? So where does 10, 20 come from? Note it's the same value as concatenating 10 and 20. The plus operator will implicitly coerce a number to a string if you try to add it to a string. Okay? Let will be a string. That's the name of a variable. We're going to set it equal to 10, the string 10, plus the numbers 20, plus 30, plus 40, plus 50, plus. Then, console logging that and console logging its type, you get this crazy thing, and it's a string. This can cause bugs if you're not sure if if you're writing functions and you don't take into account of what type will be passed in. People can pass in strings when you're doing a lot of addition with numbers, and then something like this could happen. That could be buggy, so always handle like the types of like parameters when you're writing.
What if you put all the number types in would it add 20, 30, 40, 50?
Oh, if you do like this, like a parentheses like that, yeah, it will change. Order of operations happens first, so everything inside the parentheses will add together, and then that will be added to the 10. So it'd still be 10 in front, like these will be added together. Yeah.
Earlier when we did this, it's numbers that remember it added numbers
Say it again?
it had like 3, 4, 5, 6, 3 plus 4 plus 5.
But the string was at the end.
String was at the end.
Yeah, so it goes left to right. So it adds everything first, and then at the end, then it does the thing, right? So like first it does this, then it takes this and adds it to that, then it takes this and adds it to that. You know what I'm saying? So if the 10 was at the end, like that, you'd get this, 150, right? So order is not important for coercion, but the value of the string will be different, right? So first this does 10 plus 20, which is what? 30 plus 30 is 60, 60 plus 40 is 100. So this is 100 plus a string 50, so you get this string 10,050. But it's a string. It's not a number, okay? It's a string. Is everyone okay with this? Yeah.
How come it doesn't return it in quotes?
Yeah, I don't really know what the deal is with the terminal in quotes.
So
I think if there's like one string, it's usually quotes. But then yesterday I tried to console log the strings second tier and there were no quotes. I don't know. I don't really know.
So what if you assigned a variable for that? So I or a equals that, and then you try to add it to something else, it would still be a string at that point.
Yeah. So if you said also a string, like that's set equal to this, right? And you do also a string plus 50, there would be another 50 at the end and it would still be a string. Because also a string is literally this. A string with that, right? So even if you're doing it with variable names, the variables equal something. They have a value. It's just that. It's just disguised behind the variable that you create. Okay?
In what cases would you?
It's not like a fact if you would use it. It's a fact that it happens regardless if you want to or not. So like I said, let's say you're writing a function that other people may use, and it's adding like specifically numbers. If somebody throws a string in there, the function will break. Because you're not going to like be adding the things that you want to. And sometimes you're getting data and you don't know what it is, right? Like let's say you write this for this specific amount of data, and then you think this data looks the same, like it's coming in there somewhere else. But like there's a string in there. Like it'll just be completely different. So you just have to be aware that this is happening. You know? You could find your own use cases for this if you, like, I don't know. I can't think of one right now. The most important thing is to just understand that this happens inside of JavaScript. It happens behind the scenes, whether or not you want it to or not. Okay? So let's talk about double equals. Double equals is super weird. Really don't use it. Like avoid using it because it uses a large set of rules that aren't visible to you to implicitly coerce values to the same type before comparing them. 10 double equals 10 is true. That makes sense. 10 double equals string 10 is true. That also makes sense because it's coercing, right? String true, double equals true, is false. That's kind of weird, right? Empty string, double equals false, is true. That is also kind of weird. True is double equals to a string 1. That almost makes no sense. You know? It's just like, why would you do that? Behind the scenes, JavaScript coerced both of these values to numbers. So true is coerced to 1, and the string 1 is coerced to number 1, and 1 double equals 1 is true. That's what's actually going on over here. I don't know why, but that is what happens, and it's weird. Okay? So just like don't do double equals. Like I'm pretty sure that the same thing happens here with empty string and false. I'm pretty sure both of those things are coerced to numbers, but they're coerced to 0. Pretty sure. Don't quote me on that actually, but I'm pretty sure. So double equals is just a weird thing. It does the coercion without like asking your permission. It just does it. So, and usually you're not looking to see, hey, is this string 10 going to be equal to a number 10? Like you don't want to see that. You know, they're different things. You should never be comparing those things. So, let's talk about coercing things into booleans specifically. So values can be coerced to boolean values by using the boolean global object. So you say let new bool is equal to boolean I am string. Will this be true or false? It's true. I showed you this, right? Does everyone understand why this is happening? It's because any string with any amount of characters is truthy. And that's what the boolean global object does. It checks to see if this is truthy or falsy. Not the value true and the value false. If it's just truthy or falsy. I am a string is a string with characters, so that is truthy, so it returns true. When coercing a value to a boolean, JavaScript uses rules to decide if a value should be coerced to true or false. Values coerced to true are called truthy. Values coerced to false are called falsy. Is everyone okay with this? We're not talking about the values true and false. We're talking about if this is truthy, if this is falsy. Okay? Well, truthy. Well, true is an actual. Truthy isn't a value, right? It's not a value. It's just kind of like a description of something. True is an actual value. Like you can write let this is true equal to true. You can't write let this is true equal to truthy, right? Truthy isn't a value. It's just a description, and it can describe many different kinds of values. So be careful with your terminology when referring to true and truthy. A string with characters, the number 10, an array, an object are all truthy, but they're not all true. They're all objects and strings and numbers. They're not true. True is a value. Same thing with falsity. Examples of falsity types are empty strings, zero, undefined, false, and null. Okay? Okay. So most values are truthy, honestly. Like any string, any non-zero number, all arrays, and all objects. Those are like most values that you'll be really using, you know? There are only few falsy values. An empty string, zero, null, undefined, and not a number. Okay? So recall how a conditional expression works in an if statement. If the expression below evaluates to true, then the if block will run. If the expression evaluates to true, if 5 is greater than 0, console log in the if. Otherwise, console log in the else. In the if is console, right? Because 5 is greater than 0, right? This is fine, right? You guys understand how if statements work? Cool. But you can just pass apples into this, and you're still in the if. Do you know why? Because it doesn't check, like, does this thing return true? This checks to see if this is truthy or falsy. And apples is truthy. It coerces it to a boolean, and then it says, okay, console log in the if. Apples is truthy. If this was an empty string with no characters in it, you would be in the else. So you don't have to put, like, in if statements, you don't have to put, like, triple equals or greater than this or less than that, you know? You don't have to put, like, an expression. You could just put a type. Yeah.
Is that because it's true? I get that. So like if is a type of statement. So if I'm putting string apples in there, even though it's not explicitly true.
It's truthy, though.
Implicitly true, which makes it true.
Yes.
Okay.
I guess.
I don't understand like the implicitly explicitly word to it.
Basically, if you were to put a bang bang in front of that, it would be true. If you were to convert that, anything that you can pretty much convert anything into a boolean. And if you convert that into a boolean, it will be true. So the if statement will run. You can think of it like that. If that's easier. Whatever goes inside the if blocks, if it's one value, and you can turn it into a boolean, if that is true, then the if statement will run. If it's false, it won't run. So this is helpful, like if you set things to variables, like long like expressions to variables, then you can just put the variable name in here. You know?
If you put the number 0 or 5, whatever,
If,
the
well,
number
if you,
there, that would be false C,
Oh.
and then it would run the else.
well, 5 would be truthy.
Oh.
0 would be false.
Oh, okay.
0 is false. 0 is the only false number.
Got it.
Yeah.
So if you wanted to use 0, but you just said like apples equals 0 and you put apples in there as
Wait, say that.
so say you wanted to like use the number 0,
In the
you
if?
wanted it, yeah, but you wanted it to be truthy, so you could just set 0 to equal any other word and put them there. Like say you did like apples equals 0
don't really understand.
Because you can't put 0 in there, but say
If
you
you
want to
put-
still use 0, so you can set 0 to a variable.
If you wanted to, okay, so if the main point of an if is to see if it's true or false. But if you know that the if statement, if the data type is not the data type, if the value is 0, you want to be passed into this block, right? If you want 0, like the value 0 to make it in here, you're gonna have to set a conditional in here, like if, like whatever, or the variable is equal to 0. It's triple equals 0. You have to check if triple equals 0. Because if you just put like 0, it's just going to be false. So you have to check the thing is 0. If that is 0, that's a true statement, right? This is 0. So then
So would it work if you set a variable equal to 0 and use that variable?
well, if you set a variable equal to 0, then that variable is 0. And if you just put that variable in there, that if statement won't work.
If you set that function in like apples as a parameter, does it call to see if apples is like put into the function? And then, so say you have like function tree and then apples is one of the parameters, and then you have this if statement inside of it. And
Yeah.
if apples, is that checking if the parameter exists?
So, yeah, see, so this is what I was talking about before. So, did everyone hear her? So, if there was a function over here, and the parameter is apples, and you're just checking apples here, not a string, you're just checking that parameter. If that parameter is not passed in, it will be undefined. And undefined, you can put undefined here, but that's false. So this will not run. But if you're just putting in apples here, and like she's saying, if you want 0 to go through, if you just put that there, and let's say you're throwing 0 into your function, this won't run. Because 0 is false. So that's why when I was doing that function before, I explicitly checked to see if it was undefined, the function. Because if you don't pass a parameter, if you don't pass an argument into a function, the function inside the function definition, the parameter will be undefined. Okay? Okay. So JS will implicitly coerce the results of an expression in a conditional to a Boolean value. So if 10, console log yes, else console log no. If 0, console log yes, else console log no. You get yes, no. You get the yes from here. If 10, 10 is truthy, so it's coerced to true. Yes. 0 is false, it's coerced to false, it's false. You guys get it by now, right? So, the bang operator coerces a value to a Boolean that's opposite of its truthiness. So it's just inverted truthiness, pretty much. That's why bang is also called the not operator. So you see bang true, bang ABC, bang 100, bang array, bang object. Everything is false. Even though true, this string, this number, this array, this object are true, they're truthy, but you put the bang in front of it, so what you get, what is returned, is that inverted, so you get false, okay? Does everyone understand a single bang? It's legitimately just the opposite of its truthiness. That's all it is. If this is truthy, if you put a bang in front of it, it's now false. If it's false, you put a bang in front of it, now it's truthy. You know what I mean?
So if you wanted 0 to positive, you just put a bang.
Yeah. Yeah. So like bang 0 would evaluate to true. Okay? Cool. So you can also use bang bang to explicitly coerce a value to a Boolean value that reflects its truthiness. So it's going to just tell you if it's truthy or not. It's going to do the same thing that the Boolean global object does if you pass something into it. You can think of it if you want as not. If you want to like really confuse yourselves, you know? But basically, bang bang true, bang bang that. This is all true. It's just telling you like what this is. It's a shorthand for coercing something into a Boolean. Does everyone understand this? One bang is opposite. Two bangs is what it is. Yeah.
So two bangs is kind of
Like if you do two bangs with this ABC, it's the same thing as doing capital Boolean parentheses passing the ABC into it. It's the same thing. It just tells you what it is. So if you do bang bang 0, you would get false. If you do bang bang undefined, you get false. Is everyone good on that?
and if you do type of
If you do type of bang bang that, it would be Boolean, yeah. Like it's a Boolean, right? False. Get it? Okay. So let's talk about these logical operators. I actually didn't go over this in my like little thing that I did, but logical operators are like and, or. The and or. Okay? So logical operators also coerce values to Boolean values. So both 10 and 20 are truthy values. So that's what you get. 10 and, you just say and, 10 and 20. If that's true, if that statement is true, then whatever's inside the if block will run. And both things have to be true for this to evaluate to true. I mean, both things have to be truthy for that to evaluate to true. If I did 10 and 0, that would be false and this wouldn't run. Both things on either side have to be true, okay? As you can see here, what I just said. So if 10 and 0 console log this will not be logged. And it wasn't, right? Else console log 0 is false. 0 is false. So basically, this thing says, okay, return true if this coerced is true and this coerced is true. But this is true and this coerced is true and this coerced is false. So both of these things are not true, so it returns false. Does everyone get that? And returns the first falsy value or the last value if all are truthy. I actually just found this out today. This is kind of weird. But if you do let return value equal 10 and apples and 0 and no, return value is going to be 0. It's not going to be true or false. It's going to be the first falsy value or the last truthy value. So here you say return value 2 is a string lucky, and a string number, and 7, so it's 7. I think you rarely would do things like this. You would rarely set variables to long and statements like this, because why? But be aware that that's what that returns. The first falsy value, or if there are no falsy values, the last truthy value in the string. So if this was just 10 and apples, return value 1 would be apples. Yeah. No. Every value is true to your false. Before they're coerced. Well, it's like if they were to be coerced, if it's true, it's true. You know? It doesn't have to be coerced. If it were, and that fact won't change. Like if the number 10 is is ever, forever coerced into a boolean, it's always going to be true. So 10 is true. The same thing goes with any number except 0, which if coerced is always false. So 0 is false. God bless you. Good. So the and returns the first falsy thing from left to right, or the last truthy thing. Or, that's just those like straight lines, these pipes, returns the first truthy value or the last value if all are falsy. So null or undefined or happy or pumpkin returns happy. False or null or 10 is less than 0 or not a number returns not a number. Or usually you use and or in like for like statements, like in if statements or something. Like if this and this. If this or this. If this and this. If this and this. If both those things are truthy, then the if statement will be wrong. But if it's the or symbol, only one of those things has to be true, then the if statement will be wrong. If both of those things are falsy, then in the or statement, then the if statement will not. Like, nope. So like if A, and true, you get here, right? But if this is like null, right? If null and true, here is never cancelled, right? But if null or true, you get here. You don't get here, because both are false. Get it? Who's confused by that? That's awesome, cool. So, let's continue. Never mind, we're done. So, on a recap, explicit coercion is when you are using the global, global object things, like global string object, global number object, global boolean object, to coerce things into those things. That's explicit coercion. Implicit coercion is when operators or W rules are coercing things behind the scenes that you might not want to, but it's just going to happen anyway if you're doing these things, right? If you're adding 2 to a string, the number 2 to a string, it's always going to coerce the 2 to a string, whether you want it to or not. And then we talked about coercion of Boolean truthiness, which values are truthy and falsy, what truthy and falsy actually is, conditional expressions, bang operator, bang bang operator, and then logical operators, which is like and or. Any final questions before you guys take a break and then start the workshop? Cool. So take like a 5-minute break. At 8:35, I'll slack out pairs and open the workshop, okay? Cool.